Good day everybody and welcome to the FreeBSD YouTube channel. Today I will be looking at how to manually install FreeBSD on any system. That is, basically, if you for some reason cannot run the graphical shell, maybe you're in via Getty line, or you're in some sort of live environment, PXE netboot, or maybe you've put a USB stick in and you just want to actually do it yourself for the lulz, who knows. But I am going to quickly show you this system and how it's configured. It's just basically a normal VirtualBox, no audio card, and a bridge network adapter. In the storage, I have basically plonked a FreeBSD 11.1 ISO into the CD-ROM drive, and I have added a SCSI controller with 3 identical SCSI hard drives. I haven't used SCSI for any particular reason. I think all drive controls work with FreeBSD. So let's carry on. Yes, switch. Lovely widescreen VirtualBox logo. I really wish I had something to talk about while I was doing this bit. When this actually does boot, it's actually worth trying to keep an eye on exactly what your hard drives have come up as if you are unsure. I know that on this system using SCSI they come up as DA direct access devices, what I've just gone past. And we're about to get lovely bright blue. There we go. So here we are directly in the FreeBSD shell on a live system. Nothing is being mounted from the hard drive. It's either in RAM or a read-only system on the actual CD. Now, I know that they actually are DAO on this system, but I'm going to demessage less anyhow and just pop down here. Now, the reason I'm doing this, and there probably are better ways of doing this, is just so I can show how I found my hard drives, and obviously you can see them here. DA0 VBox hard disk 1, DA1 hard disk 1, and just to keep it fresh in my mind, I'm going to do a demessage grep VBox, which should bring up, yes, all the devices that VBox has emulated, well, even though it's emulated everything technically. DA0, DA1 and DA2 are my primary hard drives, so I'm going to start with destroying the partitions on these drives, like so, DA0, DA1 and DA2, and then I am going to create a new GPT partition on them using sgpt and sgpt DA0. I just had to check my notes there for a minute, almost forgot. DA1 and DA2, and there is our partition map written out to our 3 hard drives. Now the next thing to do is create a place for the boot to go, or the bootloader I suppose the correct term is. And to do this we need to know where the start of the disk is. So if we type gpart show DAO, we can see that this one starts at 40 and that one starts at 40 and number 3 starts at 40 as well, kind of expected. So we will gpart add B40, we'll even use spaces. T FreeBSD boot, and we need a size of 512K. That looks right. Start at 40, FreeBSD boot size 512K, yep. And we want to add that to all 3 drives, for in the case that one of the drives goes missing. After all, this is a RAID 5 system, so it can suffer one drive failure. So there we go. Now, I'm also going to add a small swap partition to all of these drives, simply because, well, why not? There is a little note about adding swap like this. This is adding swap directly to the hard drives and not to the ZFS pool. In the event that a system did crash, it would be able to, as crashes in a kernel crash, it would be able to write the actual core dump to the swap partitions. If you do not want to do this and you want to add your swap partition in ZFS, that's perfectly fine. You just have to skip this next command and it will all work fine. But if the actual system does crash, it will not be able to write the ZFS swap partitions. That is the problem with using ZFS swap at the moment. Also, the ZFS swap can be a little faster if it's on a RAID array. I mean, normally I would use ZFS swap, but this is the recommended way, so I'm going to do it this way. So I'm going to add a 64 meg FreeBSD swap with this, and I think that's actually it. Oh no, I need to label it. I'm going to label it swap 0, and I'm going to put it on DA0, and I'm going to do that for all 3 drives. Like so. Now, the last part remaining is to actually add the space for what ZFS will use. And all we do for this is we set the type to FreeBSD ZFS and the label to data0 and the type disk to data0 as well, DA0. And we want to do that for all 3 drives, incrementing the number 1s for each. And we should have, if we look in gpart show, 3 identical disks taking up the entire 10 GB space on the hard drives. Now, the next thing that we need to actually do is copy over the bootloader code. And the way to do that is with gpart bootcode, which is like so. I actually do have this one written down on a note because I always forget the flags. Then end up spending 10 minutes looking through the manual page for gpart. But yes, that is all we need to do. And gpt ZFS on boot. I1 DA0. That should be the full command, I believe. Yes, it is. And we want to do that for all 3 drives, because if the first drive failed, we'd have no bootloader. So now all 3 drives should be able to boot into this system. The next bit we need to do is actually create the Z pool itself. Now to do this, we actually need ZFS loaded. And we want to Z pool create, it seems this is a read-only file system. I want to write it to somewhere that's basically, I can actually, create the folder. In fact, I'm going to create the folder beforehand with mkdir/tmp/pool. Yeah, that'll do. And then I'm going to create it. Now, the reason I've used /tmp is whatever system you've booted from, it is very likely that /tmp is writable, because it kind of has to be. Now, I am going to create my pool and I'm going to force it, and I believe that the path should be tmp pool to the root of the file, to the root of the pool. And I want to call it zroot, and I want to make it a RAID z1, and then I want to attach to it all of the data petitions from what I created earlier. GPT, and it should be data 2, I believe. Data 2. And no errors. Excellent. So if I do a ZFS list, we'll see that the zroot has 19.2 GB, which is roughly right for a RAID 5/RAID Z. And I believe it should show up in DFH as well. Yes, it does. There we go. Mounted on a /temp/pool. Lovely. So now what we actually need to do is we need to tell the system that, well, we need to tell the Z pool that it's going to be the boot device. Now the way we do this is to Z pool set bootfs is equal to zroot, and we actually want that applied to the pool zroot. Ta-da! And straight there. From here, we are actually doing a pretty normalish FreeBSD install. There are a couple of optimizations that most people set. Checksum is 1. Checksum equals Fletcher 4. I think there's actually some newer checksums around now as well, but we'll go with what we know what works. And we also want atime equals off. Atime is simply the access time for files. Most people don't use it, and it does take a little extra write, so just disable it for the sake of it. Just to the point, as we are disabling this on zroot, which is the parent of all our petitions, all the petitions will actually inherit these values. So I'm also going to set compression equals LZ4, which basically means that disk operations will use a tiny bit more CPU, but they will be a little bit more efficient because there is less data traveling over the bus. So, yep, that looks pretty good. Now we are going to go ahead and start creating the actual basic FreeBSD file system. Now, all of these are, well, actually there's only really 4 primary ones, which are the ones I'm going to create. There's actually quite a long list of small little optimizations and options you can set on different mount points to get better results. Things like disabling compression for ports, disk files, and things like that. But this is mainly just how to get off the ground on a basic system. So I am just going to create a basic system. There we go. Create the TMP, which is quite important. And we are going to do the same for zroot user, but obviously we don't want exec off for that. And the same for var as well. And the same for home. Now I am pretty sure that is all the basics covered. Oh, hold on a minute, there is var empty as well. Let me just create that one. Var empty and var temp are treated a little special, and I think that var temp is the same as /temp, in that it's exec on set uid off. And let me check. The joy of notes. There is no way I could remember all this off the top of my head. And yep, that is correct. And then finally, we have var empty, which is here. And that is exec off for that one. Now, as I mentioned, there are some other special cases for some of these. I think var run is another one that set UID off and exec off. Yes, it is. And basically everything in var has its own special options to mount with, but I am not going to step through the 10 or 15 of them they are, because these are the main ones. And I have typed empty wrong on that line. Oops. I am going to ZFS destroy the old one because, you know, we don't need a file called empt. There we go. Now if I look at the ZFS list, it should give us all of what we expected: home, temp, user, var, and all the rest of the toys. Excellent. Now I am also going to shmod 177 for var temp, which it will be the path it is on the file system. So it'll be temp pool var temp, like so. From this actual point, we are almost, we're actually about to install FreeBSD itself using 2 commands, which is quite nice. As soon as I am on the ISO, if I go into user, I will have FreeBSD dist, and in here, when my NAS decides to respond, we will have these tarbells, whatever. And the way that we actually extract these is tar xz p for preserved permissions f. And we only actually need 2. We need base and we need kernel. So I'm going to put the -c flag behind this and tell it to go into temp pool, which basically says that this is a complete tar and it should be extracted there. This usually will take a couple of seconds, especially since I'm emulating a RAID 5 array on a magnetic RAID host. And, oh, please don't take too long. Ah, there we go. So there is our base system installed, and now we want to do the same for the kernel. I mean, if you want to install everything, theoretically you could use star here. At least I believe that'd work. But we're actually installing onto a fairly small target, so we'll just use base and kernel. And then we should be ready to swap into our new system. TMP pool. And there you can see there's all the normal FreeBSD things and all of our basic configurations. Now, because we have a full working FreeBSD system in there, we should be able to swap to it with this, which change root to temp pool. We are now effectively in our new FreeBSD system, and we need to do some configuration before we try and boot into it. The first file to create is rc.conf, and in here we need to set a host name, and I'm going to call this YouTube for fun. And then I am going to enable ZFS, even though I believe the bootloader does this automatically. And I'm also going to configure my network card, and I have actually forgotten what it comes up as on a VirtualBox. I'm pretty sure it's VTnet, so I am going to add it as VTnet 0, like so. I do not think there is anything else I need in rc.conf. I am actually going to check whether that is the name of the network card though, just with ifconfig. And yeah, VTnet 0 at the top. I can spot it there. Right, so the next thing to do is to pop into /boot and create a loader.conf, like so. And the things that we actually want to put in here are ZFS load equals yes, which will load the ZFS driver on boot, before we try and load our hard drives, which will be helpful. And we also need to tell FreeBSD that our root petition is on ZFS. And the way we do this is ZFS mount from equals ZFS zroot. If you actually used a different pool name, this is obviously where I'd go here. And that should be all we need. Now I am going to touch at set resolve.conf, because I think it complains if you don't, even though I'm not 100% sure. And I am then going to configure my time zone, which is also an optional step, but we may as well while we're here. You also get a lovely blue screen when you do this. And done. Now the final step is to swap into etc mail and make aliases, which is just sets up all of the mail aliases even if we are not using them. It also helps if you spell aliases right. And speaking about mail, I actually want to make one more tweak in rc.conf, and that is to disable send mail. I actually believe that this way of doing it is depreciated now, and you should disable them all separately, but I happen to know it still works. Oh dear, I should actually go and look up the actual correct way of doing that. But anyhow, that is the Z pool created. I'm going to exit the Z pool now with Control D. And if I look in ZFS list, we can see that I've actually used some space on the Z pool. In fact, I've used 290 meg. All of the mount points are there, and everything is ready to go. So I have actually missed one more thing that I forgot about. I have forgot to tell the system about its swap. So I will actually go back into my pool, and I will create a file called etcfst tab, and I am just going to lay it out like such. Device, mount point. It really does help to actually make a note of this file before you start the installation, because I can never ever remember which way these which order these options go in. FS type ops, and you've also got dump and pass, like so. And if you remember earlier from our GPT installation of Z pools, it will show up as a GTP device as swap 0. Swap does not have a mount point, and its FS type is swap, and its options are SW, I think. Yep. And dump and pass is 0, and we want 3 of these because we've got 3 swap spaces. Easy. And so I'm going to exit out of our chroot again, and that should be our system ready to boot. The last step is to actually unmount all of the ZFS petitions that are currently on our system, like so. And if we ZFS list, they're still there, they're just not actually on the petition. If I ls temp pool, nothing will be there. And what I'm going to do is I'm going to set the mount point to legacy for the Z root. Yep, and it's also overridden all the children. Because we applied it to the Z root, it has hierarchically affected all the children. So we just need to set the mount points a little more logically, just like so. Excuse me? Did that try and mount it, I wonder? Oh, it's okay. So it appears that even though it's unmounted, when I actually tried to set the mount point for zroot home, it actually looked on the file system to see if one was there. And obviously there isn't. We don't really care about that at this moment. It should not affect anything anyway. So yeah, just be aware of that one. I wasn't actually even aware of that one until just this moment, but anyhow. So I'm going to set the mount point user to zroot user, and I also want var to do the same thing. And obviously these won't complain because these directories do actually exist on the CD. And I need to do the same with tmp too. And if we look in ZFS list, we can see that they're all correctly mounted in the right place. Now, I am quite sure this is exactly where I need to be with this system, so I am going to very bravely reboot it and hope for the best. And we'll bring this out of scaled mode for this one, because I actually need to unmount the CD as well at the same time. How actually do I remove the CD from VirtualBox when it's in this weird mode? I should have actually learned how to use VirtualBox before I did this. Okay, what I'm going to do is I'm going to power off the machine. And I'm just going to go into storage and eject that drive. Remove drive from virtual. There we go. And hopefully we'll boot into our fresh new FreeBSD system. Hey, it appears to be booting. Success! It's only the 15th attempt at actually doing this video. It's so easy to get the GPT commands wrong. So there we are, and I think in a moment, when it's finished trying to mount USB, looking up DHCP, and we're connected to the internet too. Now I actually should be able to just log in as root because we haven't set a root password, and as you can see we have the right host name and even our network is configured. And if we look in ZFS list, we should see something very familiar. So I think that's success. I mean, the one thing I will do is I will actually set a password for root, and I would just use add user to add some other users, and yeah, there we go, a working FreeBSD system from a live environment. Thank you for logging in. If you like this, please subscribe and leave any questions or requests for videos in the comments. Thank you very much.